Hey, I'm Luke with Total3dprinting.org, and today I want to talk about embedding hardware into 3D prints, particularly FDM prints. Why would we want to do this? Well, to create functional parts, things like this pocket knife here. Pins are going to allow my knife, my fork, and my spoon all to open up as I need them. So we're going to talk about three main things. First, a pin, second, a nut, and third, a screw. And we will touch on embedding this here blade into a part. Careful with the knives. I'm not going to talk a whole lot about the design of these things, but generally speaking, for pins, I want the hole in my print or my design to be 0.1 millimeters undersized. And then for things like screws and nuts, I shoot for about 0.4 millimeters oversized. The first type of hardware, and really the priority when it comes to build orientation on an FDM printer, is pins. What you really want to do is orient your pins or pin hole so that they are vertical on the build plate. Now, why is this? Well, any pin is going to see forces perpendicular to it. If you orient the pin so that it's vertical on the build plate, you're going to have filament around the pin, and that filament is going to resist those forces because the pin is always going to shear through the filament before it breaks. Contrast to this, if you had the pin laying on the build plate or parallel to the build plate, what's going to happen is that as you have your forces applied to that pin, the pin is going to want to pull through those weaker gaps or layers in that FDM filament. So priority one, always orient the pin vertical if you can to the build plate. Next, we're going to take a look at nuts and screws. The orientation for both of these is a little less important. For a nut, your forces are going to be perpendicular to the large face. And for a screw, they're going to be along or parallel to the length of the screw. In both cases, for a screw and a nut, you're going to get filament that's going to be running perpendicular to those forces and are going to resist it just fine. Alright, for demonstration purposes, I've got a cable guide that clamps around an irregularly shaped tube. I've got a pin here to join the left and right halves. I've got a counterbore for a screw, and on this piece here I've got a nut hole allowing me to embed a nut. I'm over here in my slicing software now. I'm using a Creality Ender 3 Pro printer and just the Creality slicing software. I'll go ahead and drag both sides of my cable guide in here. You'll notice that the hole for the pin is going vertical or perpendicular to the build plates. Like I talked about before, that is how I want it. Now, what I want to do is pause the print right when the hole for that nut starts closing up, right about there. I measure that out in my CAD software. That's going to be 14.5 millimeters from the build plate. So what I can do in this software is go to plugins, pause at height, and pause at 14.5 millimeters. Boom. Now, this is only so good functionally speaking in the Creality software. What ends up happening is the extruder will move away from the print and then actually immediately come back to the print. So I've actually have to keep my eye on it, and when it does that, do a manual pause from the printer. Wrapping up with the slicing software, ideally I would like to have support material just touching the build plate so it doesn't fill in that nut hole. That's going to make it easier to put that nut in. Unfortunately, I have this overhang here, so I do need support everywhere. Alright, I've done some 3D printer babysitting and I've caught it at the right time. where it's just about to print over this hole. So we've paused the printer. I'm going to take an X-Acto knife and try to get this support material out of there. You need to be really careful because if I displace this print, it's all for naught. I basically have to start over. Sometimes a pair of needle nose pliers will help. And then we can just go ahead, drop my nut on in there. Go ahead and continue with my print. Alright, my 2 halves have finished printing. You can see in there that my nut has been embedded in. I can't even see it from the outside. Now to wrap this up, put a pin in it. Like I said earlier, I like to undersize mine. Worst case scenario is you can't fit the pin in and you can just open it up with a drill here. Take my pin. Chamfered pins help get them started. And then I'll take some channel locks and squeeze that guy on in. So I've got my pin in there, allowing us that pivoting motion. To wrap up with an oddball one, I've got a print that I want to embed a knife blade into. I've stopped at the right position. I've also put in a support because really this knife blade is going to overhang this part, so this outside bit is not going to be in the final part. And what I'm going to do is add a dab of super glue, being careful not to get it on the blade itself. This is going to hold it in place in case the extruder hits the blade there. And let's just slide that right in place, fits up well. Restart the print, and we will be good to go. I can take my screw, get that started, and just like that, we've got our cable clamp ready to be tightened down. Or, like you saw earlier, a pocket knife with a blade embedded into it. So there you go. We talked about embedding hardware into 3D prints to make them functional. Hopefully this has helped you with your next project. Thanks.